Cool. So, hello, I'm Ben. So I'm on Twitter. I'm Benjamin Ben, and on GitHub Ben Foxall. If you want to see the kind of stuff I'm working on, like on GitHub, that'd be cool. And yeah, I'm really happy to be here. So thanks a lot, especially Luke. You've been messaging me a lot recently and answering my questions. It's been really cool, and I'm really excited to be here. So thanks for all that. One of the reasons I really love the tech and JavaScript community. So years ago, me and some of my friends, I think Kevin, who might be here actually, started up JS Oxford. So we kind of have had a meetup in Oxford. This was our logo with a horse on it. And yeah, I think from this meetup, I've made a lot of friends, learned a lot of things, and yeah, I've just had a really kind of fun time. So I've got a lot from the kind of the tech community and specifically JavaScript. So it's really cool to meet people at other meetups and kind of yeah, see what everyone's up to and stuff. If you look at the JS Oxford site at the moment, it's not been updated for quite a while, and the future says it's going on hiatus, which is a bit depressing. But that's because if you go to jsoxford.com, you see that. But if you go to notjsoxford.com, there's basically like an underground movement, which is like a kind of like online only meetup where we're kind of like experimenting with different things and stuff like that. So if you ever want to join us, yeah, come ahead. I think we might be stealing the Kumo space thing because that's cool. I really like that. Another thing that I'm involved in is Remote Hack. So this is something that we've been running monthly ever since lockdown started. And it's just a kind of like time just to chill, work on stuff. And it's been a really kind of good experience for me and some of the people that I hang out with. If anyone wants to join us, it's super relaxed and it'd be great to have you. It's just like some time to work on whatever you really want. It's actually on this Saturday, this month's one. So if you want to join us, you can sign up to our Slack, and at 9:30 a.m. we put in a Zoom link. Everyone jumps on and says what they're wanting to get out of the day. And yeah, it'd be, if you want to join us, that'd be cool. Please ask questions, like I said, on chat, but maybe on Twitter or email or whatever like that, because I guess we're running a bit over time, so I'll try and keep it quick. But yeah, I'm really up for questions. I can answer a lot about the JavaScript stuff that I'm going to show, but probably not so much about the kind of like broader autonomy questions about vehicles and stuff like that, because yeah, that's not my thing. So yeah, I live in Dublin and I work in Oxford. But by work in Oxford, I'm on the VPN in Oxford quite a lot, and just yeah. So I'm kind of, and I figured Birmingham is like in between the two, so it kind of works out. So I'm really happy that worked. In Oxford, as you said, I work at Oxbotica, which is a car, and we basically build software and systems for autonomous vehicles. This is one of our vehicles. It's a car, and you can see we've got this like tagline of universal autonomy. And the idea with this is we're writing software that drives stuff, and you can switch it to other vehicles in other places, and it will kind of still work, right? Like, so the example, these are like 5 cars that drove in full autonomy around busy streets in London. The same software runs a few days later in a field in Oxfordshire, where instead of navigating buses, you're navigating like sheep. And in very different circumstances, that's that same car working in an oil refinery at nighttime. So it's like, and there's some really cool challenges with that. In that, I work on the web tools team. So we build basically all the tooling that fits in between that. So whether it's showing where vehicles are, or if it's kind of like dealing with some of the data that we're getting back, and yeah, that kind of stuff. So we've got a really kind of fun team there. So yeah, that's what I do. The reason I went into so much depth is it's kind of related to what I'm going to be talking about. So this is one of our cars. You can see we've got some sensors on this one. Not a lot of sensors, but this pokey thing here is a radar. So it kind of like spins around and like bounces radio waves off stuff. This one here is a camera. We've got a few cameras around the side that you can't see so clearly. And there's a few other sensors scattered around the car. These 2 sensors here, the kind of sparkly ones, are what I was going to talk about today, and they're cool because inside them they've got lasers, right? Like, so everyone likes a laser. These sensors are LIDAR sensors, and that stands for light imaging detection and ranging. So kind of like radar, but for light. So it's in that you can, it's kind of like you're bouncing stuff off other things and working out how far away they are, but with lasers. And the reason I put the shrug emoji there is like, if people at work, if I described it this way, they would probably, they wouldn't be that happy with me, but I've done it, so that works. This is the one I was going to talk about in particular. So this is a Velodyne puck, or VLP16, I think is the code word for it. It's like, you can see how big it is. It's pretty small. You can get schematics for it, so you can bolt it onto your car or whatever. And this, yeah, gives you all the information. This is a kind of teardown blog. Tech Insights took it apart and showed you what's inside it. What you can see here, down one side, you've got lasers that fire these like beams out, and those beams come out one of these little lenses. They fire like into the world, and then bounce back into the other lens and get picked up by a sensor. And there's 16 sensors and 16 lasers, and that's why, yeah, that's how many there are. And you can see that this kind of spins around. So in the same way as you imagine a radar doing this, this is spinning around really rapidly on a car, spitting out lasers, getting bounces back, and then kind of like timing them. But the main thing I like about this this image is just like how cute it looks, right? Like it's got like two little eyes and like a little smiley face on it, and yeah, just it's a nice little sensor. So you're firing a laser at something, it's bouncing back, you're sensing that. What kind of things can we ascertain from that? So there's two things, basically. One is like how long it takes to come back, and the other one is how bright it is when on that sensor point. So this is the time of flight, how long it takes to bounce back. And from that, we can work out how far away something is. And then based on how strong that light is that comes back, you can work out the reflectance of that object. So maybe if it's a traffic sign, it will bounce back really strongly, whereas if it's a piece of like coal, it might get absorbed into it. I don't know why I picked a piece of coal there. That's a random thing. Communication. So say if you've got one of these little sensors like sitting on your desk, how do you talk to it? So basically what it is it sits on a network. So you just plug it into your router, and then it's got an IP address. And so you can visit it. You can like send it messages, just like it's kind of like having a printer, right? Like, so it's nothing magical about it. So what you do is you plug it in, you send a message that configures it. So you say like, I want you to spin at this rate, send stuff here. And then basically it just like spams you with data, right? Like, so it just like, we'll send it kind of all these bits of data at you, whatever it's seeing. So you can pull out that data. So this particular sensor sends data in 1248 bytes. So like these little packets. And so each of these bytes have a header here, and then these different blocks which relate to, so each one relates to a slice as it's kind of moving around. And then as you got these channels here, it relates to kind of like the up and downness. There's a fancier word for that, but I've forgotten it. So yeah, so this is like what that data looks like. And you can kind of pull down these data sheets. And what's kind of cool about this kind of data sheet is you can get this for all sorts of things, right? Like, so I'm going to talk about lasers, but you can get the same thing for, I don't know, like kind of any kind of binary format that's kind of flowing around, and you've got captures as a file. And it's really satisfying to pick through and work out what's going on. Cool. So the way you have this is you've got a program that sends that configuration, reads that information, and drives a car or does something else. And that's kind of that's how you use it. You have a program that does this. This is essentially what we build, but it's a bit more complex than just how it looks. Another thing you can do is like, if you want to like play this back, you can just use this tool called TCP dump, which allows you to kind of capture packets, save it to a file in a particular format that allows you to kind of like see the timestamps of those files, of those packets. Right. That was a bit of a deep dive, and the reason I kind of went down that is like to show you, to be able to describe what I'm going to talk about today, right? Which I'm going to be very quick about. So today, what I'm going to talk about is taking raw LiDAR data from one of these sensors and how we can display this in a web browser using JavaScript. I should say before we go ahead, this isn't the stack that we use at Oxbotica. Like, so we don't kind of crash into something if we get a garbage collection or something like that, right? Like, so we've got other tools for this, but we do use JavaScript for like, web tools and visualization and stuff. So yeah, it's kind of, this is a fun project here. I'm going to show a live demo just now, and we're going to kind of switch into that. And it might not work, but I hope it does. So that's all good. Okay, cool. So what we're going to do here is, right. So I've got VS Code running here. I'm going to make this a bit bigger, actually. So is that still legible? Can you make out the text? Cool, yes. Thumbs up. Cool. So what we're opening is a new terminal here, and I'm going to start a web server. So npm start. And what that's going to do is it's going to open a development server and a blank web page. And what I can do is I can go index.html, and I can say, this is a web page, and it reloads. This is using Snowpack, which is like a kind of like a really cool tool that uses ES modules quite, yeah, well, I'm moving that way. That uses ES modules as part of its kind of like tooling part. Something that's cool about this isn't actually running locally. This is running in AWS in a container there. And I've SSH'd into this, and then it's proxied my local host. It's tunneled it into the data server and allowed me to like develop remotely. So this is actually running, all this editor is running elsewhere. What's cool about this is that you can access this dev server too. So what I want you to do is like go to dev.benjaminbenben.com, and what you'll be able to see is the same thing, but it will be proxied through, well, it will be hitting my dev server, which is why this might not work. But you should be able to see this is a web page. Can people see that? Cool. Yep. And I'd kind of encourage you to like open this, because I'd encourage you to open this in your phone, on your phone. Cool, Stefan, nice one. Yeah, so yeah, get that out. And because what's going to happen is as I go through the rest of this, we're going to kind of evolve this a little bit. Cool. So we have a web page, right? So the first thing, actually, I'll just put these together. The first thing I was going to talk about was this is a website. So I've already showed, we can kind of like live reload, that should update on your phones, and we can inject, I've got some utils here. I can go into this because your JavaScripters, oh, not there, but this utils. So this thing here is basically, it keeps your screen on. So if you're on your phone, you can have it sitting there and it won't go to sleep, which is a kind of nice thing for when you're developing. And then this other thing is a kind of like hacky HTTPS proxy thing. Oh, not proxy, redirect. Cool, right, okay. So the first thing I was going to talk about is data, right? So we've got the script here, and that is in index.ts. So this is TypeScript. And if I do alert hello or jello by accident, then that should kind of come up on your phones and stuff like that. So we've got this script here. So the first thing that I'm going to do, and I'm going to just like skip ahead a little bit here, just because I don't think we have got that much time. But what I was going to do first is show us how to do some data, get some data, right? So this is a uint array. So this is a typed array that lets us generate a buffer of bytes that range from 0 to 255. And I've got this UI here, which I'm going to import from my viewers. And what I'm going to do is I'm going to render this raw data here. So what we're going to get there, index.html, I'm going to take out this is a web page. You should be able to see these raw bytes, right? So as humans, this doesn't really make much sense to us. It's like that is technically the data, but we can't kind of ascertain much. So what we can do is I've got some properties on here. I can group these together by hexadecimals. So this will put it into little chunks. So that kind of shortens it up. So you can see like 0 up to FE and not FF, 256. You can see up to FF now. Now that I've corrected that. And yeah, you can kind of, it's a bit more succinct way of seeing it. We can't really make much use of that as humans. So what I'm going to do is I'm going to colorize this, which is coloring every byte incrementally through, yeah, as a rainbow pattern. So you should be able to kind of get more of a kind of feel for the data. I am going to skip ahead a little bit. Cool. So we've got this UI. Oh, sorry.
Just quickly. There's no rush. This is awesome.
Cool.
Don't stress.
Okay, wicked.
Sorry, I won't interrupt you again.
No, feel free to interrupt. That's a really good interruption. So thanks. Sorry, I'll slow it down. Cool. Right. So what we're going to do here is we generated that data here, and we passed it to this viewer. But what we can do is we can just fetch a file. So this is fetching one of those packets, so 1024 bytes, and we're pulling out the array buffer data from it, and then we're passing that into this viewer. So when we run that, we can see this is that raw data that we're getting from one of those packets from that LIDAR. And you can see there's like this kind of headery stuff, and we've got a bit of structure. If you move this around, you can kind of get a feel for the data. So you can see these bands, and those are the kind of the columns in that data, that file that I showed you before. So you can kind of, you get a bit more of a feel for the data, and you can explore it a bit more. You can see we've kind of omitted quite a bit of this file just because we don't really care about it that much. And what we can do is we can now flick this between the first one and the second one, and we can kind of see that change around between those two. So you can see there's some things that are consistent, some things that aren't, which is quite nice. So that's us being able to visualize one of those packets of data and pull out the information just using vanilla JavaScript. Nothing particularly special here, and it's kind of handy. So the next thing, so what I'm going to do is we want to pull out a packet, a PCAP file. So what I can do is I'm going to use a bit of a library. So what this does is it pulls a PCAP file, it requests that from my web server, and then it re-emits that as packets in this exact same format. So basically it splits it into chunks. It, is that right? Yeah, it splits it into chunks and then sends it onto the UI. So now we can see this thing where it's basically like flushing through, and we're actually seeing that this is replaying data live from one of our LiDARs. And you can kind of press pause on this, and it will pause it on a particular packet. And you can kind of, yeah, play around with it. And now what we can see is, because we're animating it, we can see a bit more of the structure, right? Like, so we can see that this header here is static over all those frames, as is this part here as well. And then we're seeing bits and pieces like flash in and out. You can kind of, you get a bit of a feel for the data just by playing it live. And yeah, feel free to like pause it and play around with it a little bit more. This is really, if you're interested in, this is using JavaScript streams, like the streaming API. So it's making a fetch request, and it's pulling that request through as the bytes are needed. So it's quite efficient, and it's quite cool. Something we can do as well is I can slow this down because it's a bit fast. So this is replaying at 1,000th of the speed that data was actually collected. So you can see this like packet. And so that kind of gives you a feel for how fast that sensor is, right? Like, so as it's spinning around, it's doing all that kind of stuff. Cool. Slow down that. Nice one. Now, the next thing we can do is, so we've kind of got this raw view of it, which is kind of interesting to see, but not very useful. So what we can actually do is, I can, instead of using the bytes, I can use this debug script, which takes in that same content, but renders it in a way, it pulls out some of the raw values. So what we can see now is you can see the distance away from that object, the reflectance of that object, the azimuth, which is the distance round as it's spinning around, and then the elevation, which was that word I was looking for earlier, which is not that fancy. So yeah, it's kind of, you can kind of see a bit more of that data, and I'm going to speed up a little bit. And so you can see that azimuth increasing over time. And then once it gets to like 6.3, it will be 6.3. It will reset to 0 because that's like 2 radians, 2 pi radians. That's the thing I was wanting. So yeah, we can just pull out this data, which is kind of nice. Right. Okay. So data. What we've talked about there is using fetch, pulling out buffers, like being able to like access bytes within those, and then how to handle streaming. So we're able to kind of convert that PCAP file into like a live stream for our JavaScript. Next thing I was wanting to talk about was visualization. So we've taken this data and we've just like plotted it raw, but we can start doing some more interesting things here. So the first thing I'm going to do is I'm going to pull out this canvas, like that. So what this is going to do is it's going to take every one of these packets and plot it to a single canvas. So when we enable this, what we're doing is we're taking that exact same data. The height is the distance away, and the color is the reflectance. And so what you can kind of, and then what you can see from this is it looks kind of lasery, you know, like, so you can kind of see these, you can see a bit more of the data. You can, and it kind of like almost like sparkles. If we speed up even a bit more, it's kind of got this zappy feel to it, which I quite like. We have, yeah, so that's like a one-to-one. We're taking one packet, displaying it on one screen, but we can actually do a bit better than this by another one, which is wide, canvas wide. So what this is going to do is it's going to take one packet and put it into a slice of a canvas, and then plot it along. So what we should see here is a bit more of the actual real structure of the data. So you can see that's the exact same thing, but plotted over time, or actually over azimuth. So that's kind of, as it grows up to 6, it's going up to there, and then it'll loop around to the side. And you should be able to see this on your own devices, but you can see there's like a region over here, which are quite wide. So that means something quite close to us. There's a region up here, which is green. So that means it's reflecting stuff a bit brighter. And then there's other regions here, which are blank. So I'm guessing that's probably something that has like absorbed that laser and maybe not come back. That's what that looks like. Cool. And then the next thing we can do with this as well is actually start thinking about the 3D space that these points occupy. So what I'm going to do is, still using HTML canvas, we're going to look at a canvas circle. And what this is going to do is it's going to plot that content using the kind of azimuth as an angle outward. And you can see here we've got that region that I think was close to us here, which looks like a car. We've got this reflective region over here, which looks like a flat surface. So it must be some kind of a window or something like that. And then over here, we've got some wall. And then here up at the top, you can see some trees, right? Like, so you can kind of, we're able to kind of actually make out more content by switching it around this way. Cool. So what we've talked about there is how to understand that content and actually kind of plot it to a canvas element. So be able to like use these kind of canvas primitives to say like draw this square here, and just based with that and some maths, we can start actually kind of seeing the structure of the data, and you can kind of have an idea of some of the things that are there. The next thing I was wanting to talk about was graphics. So that's using the Canvas API, which isn't always the most performant way of doing it. So what we can do is if we use something, we can take a slightly different approach, which is to, instead of rendering stuff directly to screen, render it into a buffer, like a kind of a bit of data, and then in a separate process, render that data to the screen. So this is a really common thing in WebGL. So what we can go from, I'm going to switch it back to canvas wide. What we can do is we can use a WebGL viewer, and that is going to do it in this way, right? So I'm going to go, is it GL, WebGL? Right, okay. So this is going to separate the viewing and the kind of parsing of that data. So as I save that, you should be able to see sweeping in from the side. It takes a little while. We're seeing that content here. And if you touch it, you can kind of move around. So we're kind of like, we're able to move. We're able to kind of like animate even while the data is kind of flowing in, right? And what's nice about this is you can actually see as you move it up and down, it is 3D. So we can actually zoom out with the mouse, and we can actually kind of like look around this 3D scene. So this is that same data that we were showing in the canvas, same data that we were showing in that kind of like binary view, and we're able to access it in a kind of richer environment. And this should also work on your phone as well. And what I'm going to do is I'm going to change this to true here. So this is going to start up higher, and you should be able to see that coming in here. Have we got more to cover here? Yeah, probably. Okay, cool. So one of the nice things about separating these out is that we can actually, this is a lot more efficient. So we can speed up the rate that this is playing at. So we can actually just play it at real time, and you can see, it's still as responsive as before. But you can see now that we've hit a problem that because we've got this really small file, it's not really kind of giving us much to play with. So what I'm going to do is I'm going to change this to, I think 15, 10, 20, 25. Yeah, we'll go for 25. So this is a larger file, and you can actually, we can play it a bit further, and you can see some of the more stuff that like cars coming in here and around like that. Actually, I will switch this back down to 10 because that's going to be a bit easier. Cool. Right. So now the next thing we're going to do is we're going to talk about shaders. So in WebGL, you've got this other language as well, which is like GLSL, which is a so in this view, there's basically in this pipeline that I mentioned, part of that pipeline runs these things called shaders, which are a different language from JavaScript, and it kind of compiles into that pipeline and can do things quite efficiently on a GPU. So we're going to play around with that a little bit here, and you should be able to see these updates live. So what we're going to look at is the vertex shader first. So this has got some bump around it to start off with, but what we can do is we can set the color here. So what we can do first is, so these are all just like a single pink color, but if we color this by the distance away from that central point up to 50 meters, we can kind of see this rainbow. So you can see which things are further away from others. So we can start seeing, oh yeah, these trees are quite a lot further, and that's maybe about 50 meters. We can bring that down to 30 meters, so you can kind of see the scale of this. What's quite nice is these units are meters, so you can kind of play around with that. You can also play around with like, we can color it based on the XY position. So that's now kind of coloring out that way. And to avoid this, so you can see how it gets cropped when we do this, even though it looks really badass. We can change this to use a sine wave. So this is that same thing, but using a sine wave. So I think this is colored by Y. So this shows us the height. So you can basically make out which objects are higher than others if you can like look around and stuff like that. Cool. What's nice and fancy as well with these is really efficient to have these things called uniforms that change over time. So here we're using the position and time as well, using that same sine wave for coloring. And when we do that, we get this kind of pulsy, animate-y thing. So you can see, yeah, it looks pretty futuristic. And then one of the ones that's more useful is to use the intensity, right? Like, so this shows us which objects are reflecting more. So you can see that's the reflective object before, that kind of flat thing there. If you see over, as this goes over, you can see in the distance, oh, that's really not very useful. You can see that's a sign over there because it's really reflective, and other cars. Yeah, so basically you're able to kind of like pull out that content by coloring it that usefully. Cool. The next thing, right? So if you zoom in to one of these points and you're looking at this, there's something wrong with this. I mean, there's a lot of things wrong with it, but something that is wrong with it is that as the points get further away, they're actually the same size, which doesn't match how things are in real life, right? Like, so what we can do is if we apply the sizing based on how far away the camera is, which is called size attenuation, when we do that, you can see that the things that are closer to us now are bigger, which is a bit more natural. So, and that, as you're spinning around, kind of gives you a bit more of a kind of feel for the data, you know, like it feels a bit more natural. And so you should see as you're playing around with it, that you can kind of, it just feels a bit more realistic. Another thing that is useful is like we can also alter this by how far away goes from the laser, which is like, so the laser is actually a cone, right? Like, so it actually, as it goes out, it's covering more distance. So we can emulate that with this shader as well. So now we can see when it's hitting trees in the background, it's actually covering more distance than when it's hitting stuff closer to it. So you can kind of, yeah, you can go down a lot of rabbit holes with this kind of stuff because it's very, very fun. And we can do this, which I really like. So this one here, this is using time for the sizing. And what you get is an effect where particles pulsate as they're more reflective, right? Like, so this pulsing, it gets faster as something reflects more, like, so a traffic sign or something like that, which is like the most useless data visualization technique ever, just in case you're wondering. Cool. Then the next thing I was going to talk about quickly, actually, no, that doesn't matter. I won't go into that much detail. Cool. Right. Okay. Yep. I will carry on going. Cool. So we talked about WebGL and this pipeline stuff, and I'm sorry for rattling through this so quickly. I've got far too many slides. So I just wanted to quickly end on talk about other devices. So the nice thing about the web is that it supports, you can open it in different browsers and entirely different devices. So one of the cool devices, so basically this same, oh, sorry, I can't drag that. This same app works in, sorry, one sec, in Safari or Firefox or on a phone or on a tablet. But nowadays we've got some very different devices. One with web browsers, isn't it? One is like this, which is a Oculus Quest. And I'm going to try and show you a bit of a demo of this same site in Oculus Quest. Bear with me one sec, because it takes a little bit of setting up. So continue, confirm, switch stationary boundary, confirm. Cool. So what I'm going to try and do is I'm going to try and cast to computer, pen Foxall. Cool. Sorry, this is like the most awkward thing to show ever. Has anyone got an Oculus Quest out of interest? Cool. Aaron does. You can load this in your thing as well. Right. I'm just going to change this to WebGL true as well. Cool. Right. Okay. So what I'm doing here is, sorry, this is really awkward with there. Can you all see that? Cool. So this is what a web browser feels like in VR, right? So I've got these two handsets here. I can go down to my apps here. I can open a web browser. It seems to have crashed, which isn't what we want. Cool. So what I've got is I'm connected to that same device. These controllers, I can kind of like navigate it like it's just a website, right? Like I can even press that button to pause it, or I can unpause it. But now something that I've got that's new is this enter VR button in the bottom, which is something the script put in. When I click that, it takes me into the space, right? Like, so I can now kind of like look around and see that kind of car. I can pause it with this, and I can move around here, and I can kind of, like now I can experience this in quite a kind of different way. Like I can sense the distance to things. I know how big stuff is. I can walk over here and I can actually see there's a person walking here, and it's a lot more visible in VR, right? Like, so I can actually make out that person's foot, which is kind of nice. Cool. So that is that. So something that's quite nice, so that's a VR headset. Something that is pushing WebXR forward is the fact that you can use it in augmented reality devices. So again, what I'm going to do, and I will try and be quickly with this, is I can cast from this phone. And what we should see is, right, so this is me on my phone here, and I can navigate around with just touches, and some of you should be able to see this before. But I've also got this enter start AR button, which is going to show you, there's everyone, hello. But we can also see down here, we've actually got that same content in augmented reality. So I'm able to kind of walk around and actually kind of like walk up to stuff, see that car, see it pulsing, and yeah, that works there. Hello. What I'm going to do here is I'm going to show you something that I think is quite cool. So what we've got is here's my hands, and those are the controllers. What's nice is these options here still work even if it's in augmented reality. So we're getting live reloading through an augmented reality device. So if I was to change the color from intensity to that rainbow, so you can now see that it's changed, and we're able to kind of like live code and do live reload on a device that is in augmented reality. And we can kind of switch things up. Like if I change the augmented reality scale up a little bit, it'll get a bit bigger. And it's to me, this is really interesting seeing stuff that we get to use as web developers applied to VR and AR in entirely different spaces, like literally. Cool. So that is going down there, and you can see this still works as well. Right. Cool. So what we talked about there is WebXR, kind of. That's that API that facilitates all this. Virtual reality, different kind of browsers that work in completely different contexts, and augmented reality down here, which allows us to kind of get easier accessibility. And this stuff what's nice is like it's improving all the time, right? Like so iOS is kind of on the way, and this is an Android phone, a Pixel, but yeah, it's going to be more and more accessible. So what we covered is capturing data, visualizing it, pulling out content, drawing that content to those canvases, graphics pipelines, and extending into other browsers and stuff like that. And I guess the last things I was wanting to talk about was like just like the idea of exploration, right? Like, so we've gone from visualizing raw bytes and hexadecimal digits through to live coding on a mobile device that is just like doing something very different. And that's a very kind of like incremental and explorative kind of process. And I think something like that really struck with me was like when Becky mentioned about like doing what you love, you know, like, so I think it's really, and doing katas and things. And I think there's something really cool about embarking on projects just for the fun of it, you know, like, and kind of like learning stuff. So yeah, I really enjoyed that. Do we have like 2 minutes for me to show a quick video or something?
Yeah,
is
definitely.
that right? Or do we need to wrap up? Cool. Wicked.
Yeah, definitely.
So I was just going to quickly show something just about the kind of scale of the stuff that we do at work. Oh, sorry, I'm having trouble with this sharing thing. Cool. So that was using quite a kind of like a bit of an old school, not an old school. This was using a sensor that has these 16 channels, whereas I want to show you quickly some of the other sensor data that we deal with. So this is a screenshot from a web page that's kind of zoomed in from one of our internal tools, and you can see the density has changed, right? Like, so this is actually several rotations over time. So this is actually, it's actually not time, it's distance. So this is like a meter traveled, I think, or maybe 10 centimeters, some amount traveled, and the kind of scans that have happened in that time. And you can see how much more dense that data is than the stuff that you can see on your phones, especially as I zoom in. When I zoom out, or yeah, there you go. You can see it's kind of covers a bit of a wider area as well. And this is actually, what's nice about this data set is this is actually outside our office. So I know this space pretty well. But you can see in that 10 centimeters that we covered, we've actually captured stuff that is like way off in the distance, because this is like a bit of a kind of higher resolution sensor. As I said, this is over distance, not time. We can capture that over a longer period of time. So what we're going to do is we're going to change this to capture as the car was driving from here, or not all around there, but just up to the end here. And we can visualize this all. This is just a web page, and we can visualize this, load this data in, and you can see this kind of like richer data set that we've got here. So you can make out the bushes, the trees, the vans, and all that kind of stuff. And it's kind of interesting. The next thing I think is, so this is playing with those uniforms. So we're able to kind of like explore the data a little bit by changing properties and viewing it by different different properties. This what is nice, like, so this kind of stuff I love. This streak here is 2 people walking along. So because we've captured it over time and those people even walking, they appear like a streak in a 3D space. Something that's also nice is you can see off to the left here, there's these 2 other lines. That's actually a reflection in this window here of those people. So you can see you're getting like 3D reflections of objects. And someone pointed out actually, so this is the van here, and we've got this other van here, which is a reflection. And in the reflection, we can see inside the van, right? So basically the laser's been coming from here, bounced off there, hit inside the van, but reflected round. So you can kind of like, see a bit closer in there. You can see this is a reflected staircase inside that building. This is something else. So because we've got multiple cameras on our sensor, on our cars, we can actually combine sensors together. So I'm going to switch to view mode here to basically project the camera photos into that 3D point cloud. So what you can see now is you can see the color of objects because we've been able to combine those sensors. So even if we don't have the LiDAR sensors, we're able to kind of project between sensors and pull out this content. And yeah, something that's nice here in that. So the LiDAR can see behind us, whereas the cameras are pointing forward. So that's why these points are black, because we don't have any color data for them. So you can kind of like, all this stuff is kind of fun to think of. And then this is reflections. But yeah, that's pretty much it. So yeah, thanks a lot for listening. I'm sorry for going so much overtime and stuff like that, but I hope you enjoyed it. And yeah, I'm going to be kicking around later and drinking wine or beer, or possibly both. So yeah, yeah, that's that. Lasers.
Awesome, thank you so much. That was genuinely brilliant. Like, I don't think I've ever been so interested in data. That was really cool. I was playing along on my phone.
Cool.
Brilliant. Well, thank you very much to all the speakers this evening. Thank you to Ben. Yeah, thank you to Becky, Stefan, Helen, and Ben. This has been brilliant. I think some of the best talks we've had. So really appreciate you coming along to the relaunch.